this section, we're going to be taking a closer look at various types of sampling. Now, sampling is a method of selecting members from a population and creating a subset that can then be used as representative of the population as a whole. So, there's several different types of sampling we can look at. Simple random sampling, systematic sampling, stratified sampling, and cluster sampling. So, we're going to go through and look at each of these with an example of how it would be applied to drawing 8 cards from a deck. So this makes it a pretty small, simple example, and for those of you that are tangible learners, I suggest you get a deck of cards and actually go through these steps if that helps you really cement this understanding. Then, after each example, we're going to apply it to a more complex problem that's a little bit more real life. First is simple random sampling. Now, this is sampling where individuals are selected in such a way that every possible sample of the same size n has the same chance of being chosen. That sounds a bit complex, but let's take a look at what we're actually looking at here. So, for example, for a deck of cards, just spreading out the deck of cards and having someone draw 8 cards would not be sufficient. You'd have a host of different problems, such as cards potentially sticking together or any other thing that might slightly interfere with this. So, the easier and more accurate way of doing this would be to enter each card into a computer file and then run a random selection program to pull out 8 cards. Thus, each card would have equal chances of being sampled into the sample set. Let's look at this more real life issues such as selecting students from USF. Let's say that I want to randomly select 400 students from USF to use them for a study. I would go through and get the parameters of all the current student ID numbers and set them into a random number generating software program. You can actually get these for free on the web. If you go and you Google it, you'll find a host of different programs you can use, and you would go through and set the particular parameters. Now, after I'll ask it to go through and randomly create 400 numbers using those parameters. This makes it completely random. After that, I go through and I collect those 400 numbers it's randomly created to the actual student IDs and collect the data from those 400 students. This would be a simple random sampling of students at USF. All right, the next one is systematic sampling. So this is when we select some starting point and then select every k element in the population, where k is a set number. So let's think about this yourself for a minute, thinking about a deck of cards, and go through your mind and think about how would you do a systematic sampling from a deck of cards, drawing 8 cards. So stop the video here for a moment, think about that, get your ideas, jot them down, and then let's take a look at this together. All right, so you set k at a certain amount. Let's say 6 for this example. And then starting at one end of the deck, you pull out every 6th card until you have 8 cards total. That would be a systematic sample of 8 cards from a deck of cards. Again, applying this to our selecting of students from USF, I would place all the student IDs in a single file and then pull out every 50th student until I had a total of 400 students. Now we're going to look at 2 of the more complex types of sampling. So this is stratified sampling, and then in a moment we're going to look at cluster sampling. In stratified sampling, you subdivide the population into at least 2 groups, often called strata, so that subjects within the same group share some predetermined set of characteristics, whatever it is that you may be interested in. You then draw a sample from each group. So again, let's pause the video here for a moment and think about this with a deck of cards. So, how could you break up a deck of cards so you had at least 2 strata? And then, what would you do from there to draw your 8 cards? Once you've got that jotted down, you're ready to move forward, let's take a look at it together. Alright, first you'd select a criteria and create strata based upon it. So in this example, I use suits: hearts, spades, diamonds, and clubs. So, I have 4 suits, and I'm going to draw 2 cards from each strata or suit, and this gives me my total of 8 cards. Now, notice I could have set this criteria for several different things that would have produced different strata. So I could have set it for colors, black or red, and that would have given me 2 strata. I could have done it by denomination, so 2, 3, all the way up through king and ace. So these are all different ways that I could choose to break down the population of a deck of cards based on certain criteria. Applying this back to looking at students from USF, I would organize the students into groups based on their majors. For example, I'd have 64 groups. I then select 6 students from each major. Now notice we are 16 students short of our total goal number, so I would then draw one more student from 16 of the majors. So stratified sampling is not necessarily exactly the same individuals at each strata, but it should be very close. Again, looking at our idea of sampling students from USF, what are other organizing criteria that I could have used? Well, I could have looked at class standing, like freshman, sophomore, junior, senior. I could have looked at gender, race. I could have looked at whether a commuter or a resident. I could have looked at age. Any of these could have been meaningful strata to break down the overall student population into, depending upon the research questions I'm interested in answering. Now, cluster sampling. This subdivides the population into sections or clusters so that the subjects within the same subgroups, again, share some predetermined set of characteristics. However, here is where the big difference occurs. I then choose a set number of these clusters and use all members in those clusters. Notice I'm not pulling individuals from each strata, from each group. I'm selecting a subset of those clusters and using all the members in those clusters. So let's apply that to a deck of cards. What would that look like? Well, here, for example, I would use denominations such as 2, 3, queen, all the way up through. I would then choose 2 denominations, let's say 5 and jacks, and I would draw all 4 cards of each of those denominations. That would give me my sample size of 8 from a deck of 52 cards. Notice that this gives me a very different composition for my sample than the cluster sampling approach. Applying this to looking at students from USF, we would use the same approach of setting clusters. Then we would go through and choose a set number of all of these clusters and use all members in those clusters. So if I have 64 majors, I would select all students in 8 of these majors. Now hopefully this explanation of the difference between stratified and cluster will help you keep these two straight. I suggest you get these examples in your notes and identify them and break down how they would give you very different samples, because this is a really easy mistake to make and students do it all the time. And again, you lose points on your homeworks and your exams for not being clear about the distinction between stratified and cluster sampling. Now, let's take a moment here, by the way, and think about stratified sampling and when it might be really particularly appropriate and accurate to use depending upon the questions I want to ask. So let's say I'm interested in student retention at St. Francis University. It's a very common concern in academics. And we want to look at this in terms of the makeup of the student population. So if I'm thinking about the makeup of the student population, most of the students at St. Francis are within the age of 18 to 25. So if I was doing a random sample of all of the students that are at St. Francis, so let's say we're using that approach from the beginning where I'm running a software program and getting ID numbers and then matching them with students, my population would be predominantly of younger students. The few students who are non-traditional students probably would disappear in that larger set. So let's say if I was doing my 400 example, I might wind up with, in fact, it would be very easy and likely for me to wind up with something like 395 students that are within their ages of 18 and 25, and only 5 students that are non-traditional students looking at 40 and above. So those 5 students' experiences would literally disappear in my data of the other 395. They would just be awash and hidden in the other numbers. So using a simple random sample to look at issues of retention for students at St. Francis would tell me a lot about the dominant population in terms of age, but would not allow me to address an important subgroup that's smaller, but perhaps has unique strengths and weaknesses that I need to know about. So if we were doing that, A similar example looking at this with healthcare would be gender differences in heart disease frequency, symptoms, and treatment. If you look at this image over here, we can see, for example, the different major signs and symptoms of a heart attack in women and men. Notice on the right, men are more likely to have chest pain and discomfort, shortness of breath, and pain or discomfort in the arm or shoulder. These are traditionally thought as the signs of having a heart attack and are reasons to see your doctor. It's very important to pay attention, however, that we see on the left, women are also likely to have those symptoms plus or rather than other symptoms, such as having nausea, feeling lightheaded or unusually tired, and having pain or discomfort in the jaw, neck, or back. These are symptoms that are more unique to women. Now, if this means that if I wanted to look at the major symptoms of a heart attack, I would actually want to use a stratified sample, as they did for this research, between men and women. This represents a problem with some of our healthcare research. So, early healthcare research was done solely with men. Thus, the symptoms for men were then generalized inappropriately to women and have caused serious problems in our diagnosis and treatment of heart attacks for women. So women currently are more likely to have a severe heart attack without previous diagnosis because their symptoms, showing the nausea and the feeling lightheaded or unusually tired, and pain and discomfort in the jaw, neck, and back, are usually dismissed by them and even sometimes by healthcare practitioners as not being indicative of a heart attack, so they do not follow up with treatment. So this is where stratified sampling can literally be an issue of life or death. Again, looking at marketing is another important area. So I'm wanting to look at marketing my particular item to homemakers. However, we are having a higher rate of male homemakers lately, but they are still numerically not as high as female homemakers. And again, because they're different, they may have unique strengths and weaknesses or issues and concerns that are not shared by female homemakers. So if I was wanting to look at how a particular product would market to homemakers, I might not want to do just a simple random sample, but a stratified sample where I was looking at both traditional female homemakers and also non-traditional male homemakers. This would allow me to look at similarities across the groups and also perhaps important differences that would help me improve my marketing. Similarly, if we were looking at immigrant professors, so professors coming into the United States of America and working here in our country may have unique strengths and weaknesses as professors. So if I'm a university and I've recruited professors, which costs quite a bit of money in terms of advertising, paying for them to come in and visit, and getting them trained and get up to speed, of course I want to maintain these professors. I've invested a lot of money as an institution to bring them here. So what can I do to help improve their retention? Well, again, professors who are citizens of the United States of America may have very different concerns and issues than individuals that are immigrants. So if I want to make sure that I'm putting a program in place that's going to help me retain all of my professors equally, I would probably want to use a stratified sample where I would be looking at both professors that are born in the United States and those that have immigrated to the United States. This would help me, again, look at similarities across the groups and also important differences that I need to pay attention to. So, when we're looking at stratified sampling, it helps us get a detailed knowledge about populations and topic areas that may be critical for making appropriate sampling plans. So, again, looking back at our example of retention at St. Francis, if I was going to be looking at retaining all students, I might want to do a stratified sample looking at different age groups so I can identify age differences. I might want to look at differences by major. Are some program areas doing a better job of retaining their students, or are some program areas losing more of their students? Again, that could be really important information to have, and once again, I'd get it by doing a stratified sampling. All right, now we're going to look at using a real-life application of sampling, solving one of the questions you have in your book. So, on page 26 through 27, they give you a really great breakdown on how unemployment data is collected through the U.S. Census. So we need to go through and look at how they do this approach and identify each particular sampling style as we go along. So the goal here is the collection analysis of data that accurately represents people in the United States of America, but is available rapidly for use in current policy decisions, healthcare interventions, etc. So, getting data regarding outcomes in 2012 and understanding it by the time we're in 2016 is not very useful. We need to have a rapid turnover so we have that data now to be able to make intervention and other appropriate policy changes. So the U.S. Census has a very unenviable job of collecting a very large amount of information from a very small sample that still needs to be roughly representative of the United States of America, and indeed break down roughly representative for each state. So let's take a look at how they do this. So when you're reading through the problem, it looks pretty complex. In fact, you are correct. This is a very detailed process, but it is actually really quite exemplary. I looked into it a couple of years ago, and honestly, I'm really impressed by the accuracy of information they can get in terms of you working with such a small subset of a group. So let's work through this step by step. First, read through the whole example first just to get an idea about it, and then let's walk through it step by step and break it down. So, first, the USA is partitioned into 2,052 different regions. These are called PSUs, which are geographically connected. So areas that are urban, rural, etc. These are then grouped into 824 different strata, okay? And each of the 824 different strata, one of the PSUs is selected. Notice here, though they're using the term strata, they're still only selecting one of the PSUs. So, what type of sampling method would this be? This would be cluster sampling. Remember, in cluster sampling, we pick one category and we sample everybody from it. So this is a cluster sampling. Don't be fooled by the use of the term strata. Okay, 2. In each of the 824 selected PSUs, a census enumeration district is identified. Each of these then contains about 300 houses. Enumeration districts are then randomly selected. So that means within each of these 824 selected PSUs, they break them down into enumeration districts. All of those enumeration districts across all of those 824 PSUs are then randomly selected from those. So, what type of sampling would this be? This would be a simple random sampling. All right, so now we've used two different types of sampling already when we're looking at the U.S. Census data collection. All right, number 3. In each of these selected enumeration districts, clusters of 4 addresses are selected randomly. All respondents in these addresses over the age of 16 are interviewed. This is an example of what? This is again an example of cluster sampling. So we've gone through in each of these selected enumeration districts, we've got 4 of these clusters are randomly selected, and then we interview all individuals in that specific 4 address cluster. So this is a cluster sample. So here, what we're looking at is a multi-stage sampling approach, which is where you use several different types of sampling at each level to collect data analysis of data from a very vast population in a timely manner. So they get all the way down to 60,000 selected households through careful sampling design. And this helps us learn some very important information. So, for example, we can see here the data from 2013-2014 is posted on the U.S. Census website, shows the uninsured rate of working age adults decreasing in the United States of America, and indeed actually shows us how this connects with state Medicaid expansion status. So, this is really important information if we're wanting to look at, is the state Medicaid expansion status making a difference or not? So, you can check out other information and other examples at the U.S. Census Bureau if you want to, the link of which is posted on the Blackboard site as well.